Alrighty everyone, we're going to jump into another statics problem. This one is from spring 2017. It's your exam 3 problem, or at least not my, but it was the exam 3 at the time. Your exam 2, just because of the strange format that they picked this year. So we'll go ahead and get started. This is a truss problem, if you couldn't tell here. Hopefully you could. So the problem is saying the truss is supported by a pin at F, a triangle here, and a roller at C, the circle here. The first thing it wants is us to draw a free body diagram of the truss. Next it wants us to determine the support reaction at roller C. And then C is draw relevant free body diagrams and determine the force in member AB. So we'll put a star there. In the force member BE. Uh-oh, I see a trend happening here. And the force in member BD. Never mind, the trend was killed. Anyway, it says report whether each is in tension or compression. And it says solution without supporting free body diagrams will also receive 0 credit. So that's fun. Anyway, what I was kind of talking about with the trend, in case you guys were wondering, is where I drew the stars. These are the forces that we're looking for. I was thinking that if they asked for all 3 of these, then we would use method of sections, and method of sections only, to solve for that. But that's not the case. Well, I'll have to take a deeper look into this as we get going, but for the time being, that might not be exactly the best way to go. But anyway, we'll go start with part A. It says draw a free body diagram of the truss. As you guys know by now, there are these little answer boxes at the bottom for you to draw your free body diagrams or report your answers. So we'll go ahead and draw those in. And I'm just going to go ahead and draw it in this box here. We could draw it out here, but then we'd have to report it in the box eventually. So might as well cut out the middleman for now and draw it out here. I'll go ahead and draw another straight line. It doesn't have to be perfect, but just try your best. Of course, in the middle of the exam, it's good to bring a straight edge. One of the most common straight edges is your student ID. That's one that is easy. You'll need it anyway because we're supposed to check your IDs. Make sure it's actually you taking the exam. A bit much, I know, but I guess they like being secure. But yeah, go ahead and make sure you bring your student ID. And if you don't want to bring a ruler or don't have a ruler or whatever, you can use that for your straight edge. And it's kind of easier to use on the small little tables that we have in the exams too, and those lecture hall tables. Not the biggest fan of those. I like to sprawl out when I take tests a little bit, but I guess it's okay. At least they're already socially distanced, so we'll go ahead and draw these in. Free body diagram of the truss. So F, we were told, is a pin, and it's drawn as a triangle. So we're going to have F, Y, and Fx. C was given as a circle, and we were told it is a roller, so it's just going to be acting upward, Cy. And then we've got the 2 applied forces. We've got 10 kips going down, 20 kips going down. And then dimensions. You'll still want to put in dimensions here. You don't really need a straight edge for those as long as you're halfway decent there. Looks like these are 2 feet tall. Here, it might be a little small for you in the video, but 2 feet is the height. And then we'll go ahead and draw this out on the bottom. And these are all 2 feet here, which is good because this is kind of shown as a square, so it's kind of to scale. So 2 feet, 2 feet, 2 feet, 6 feet total in length. So we've got the free body diagram of that. We'll just put a little check mark by the problem, like, woo, we got it done. Next, we can determine the support reaction at roller C. So we want to solve for Cy going up like that. And I can kind of see why they're just asking for Cy. A lot of times in exam problems, they'll kind of have part A lead into part B and part B lead into part C. It's kind of nice. They don't directly tell you, but they kind of show you how to solve the problem without outrightly solving it for you. And they kind of give you ideas on what steps to take. This could shoot you in the foot too if you don't know how to do part A, but it leads into part B. Then you might be a little SOL, but a lot of times in those cases, if you do know how to solve, for instance, let's say you know how to solve part B, but you don't know how to solve part A, then you know you can always just choose maybe a random number for part B. And as long as you do all the correct work for that, You'll lose points for not having the correct answer, but you should get most of the credit for doing the right work. You won't get points for part A if you don't know how to do that, though. So in this case, it doesn't quite apply because it's a free body diagram. Hopefully you guys know how to draw those by now. But we've got a free body diagram here. We can go ahead and use that to solve for CY. And we'll go ahead and sum of the moments about F right here. About F. I guess another thing in our free body diagram, it wouldn't be a bad idea. They label all of these little joints here. We can go ahead and label those while we're at it. So we've got F, A, B, C, D, and E. So it never hurts to have too many details on your free body diagram, as long as you don't draw something that's wrong. Sometimes you might try to force another detail in there and then find out it's wrong. Like if we were to draw the internal forces here or anything like that, that would not be correct. We're just looking for the whole truss, not any internal force or anything like that. So if we sum for the moments about F, we are going to have, looking at our free body diagram, get this in a way you can see both. First thing, we're going to have CY, and it's going to be going counterclockwise, so it would be positive. CY times the total distance, 6 feet. 2, 2, 2 is 6. Next, we'll just go from out in. So we're going to have the 20 kips, so minus 20 times the distance is 2, plus 2 is 4. And then next we're going to have the 10 kips, which is going to be, again, negative. And this is 2 feet away. And those should be the only forces causing a moment about F. So we've got those. We'll go ahead and calculate out for CY. CY is going to be equal to, let's see if I can do this without glare on my calculator. Yeah. 20 times 4 plus 10 times 2. We'll just take that whole thing divided by 6. And we've got 16.67 is what we'll say. 16.67 should be kips going up. Well, that's your answer for CY right there. So we can go ahead and box that. We're already through part A and B. Wow. It seems like it's going kind of fast. Part C will slow us down a little bit, but that's okay. They kind of expected that. So go ahead and just report this 16.67 kips going upward. That should be correct. It's pretty easy to solve for as long as you know free body diagrams and whatnot. Next, we're going to go ahead and move on to part C. Okay, so for part C, draw free body diagrams, determine the force, and AB, BE, and BD. Oops, sorry. AB, BD, and BE, and BD. Everything that we've started. So we're going to go ahead and solve this using what we do to solve for trusses. Now, I think for trusses, there should be a few steps you should follow. I'm going to write them out here. So number 1 is going to be 0 force members. So the first thing you're going to do is look for 0 force members. Next, you're going to want to solve for reaction forces. This isn't an exact order, but this is stuff that you need to do. So first thing you should always do is solve for look for 0 force members. Then solve for the reaction forces that you'll need. Number 3 is going to be decide on method. And 2 and 3 can be switched before you can know what method. It might be helpful to know the method before you solve for the reaction forces. And then number 4. I'm not sure if there is a number 4. I had a number 4 listed before, but now I can't quite remember what it was. So my bad on that. But ultimately, if you get these 3 things down, these are pretty unique. The rest is just solving for equations, so equilibrium equations from there. / FBDs. Ultimately, yeah, the first thing you should do is look for 0 force members. They can really simplify a problem for you. The next thing you'll want to do is solve for the reaction forces. You're going to want to solve for the reaction forces that you're going to want to need, which will make more sense if you decide your method. But the method, I'm going to draw a little arrow because I think maybe they should be backwards. But the method, you have method of sections and method of joints. Method of joints is where you go bit by bit from every joint in here and draw like a free body diagram. So if I were looking at B, it would be something like BD, BE, AB, and BC. That's a joint, method of joints. Whereas method of sections is if, let's say we wanted to solve for these three forces here, we draw a cut through them and expose their internal forces, whether they're in tension or compression. So that's where you need to decide your method. And then using that, you can kind of see what free body diagrams you're going to need, and then solve for the reaction forces that you need. So for example, if we wanted to solve for BC here, then you'd want to probably use method of joints here at C. Well, using method of joints here at C, you're going to need the reaction force here at C. And while we'll need the reaction force here at C to solve for this beam here, we won't need the reaction force at F. So there's really no point in wasting time solving for the reaction at F when you're not going to need it. And that's kind of one thing this problem is doing, is they see that you can use this right side of the truss, and you're going to need Cy to solve for the internal forces in here. And that's why they asked for the support reaction at C. And, sorry, I lost my train of thought. You're going to want to determine the support reaction at roller C, and that kind of leads you into solving the next few problems. From here, if we look at our truss here, I think maybe the best method is to solve using method of sections. But first off, I skipped problem one, or step one. Step one is look for zero force members. Well, zero force members are going to be members where there's either a T junction and another another beam acting upward. This beam here is going to be zero force. Or another zero force is if there's some sort of corner like that. These are really bad drawings, but if there's some sort of corner like that and there's no external forces acting on it, they would be zero force. So if we look at our beam here, we can look for corners and T junctions. I see a T junction right here at D, and it means that BD here is going to be zero force. Well, we can go ahead and draw a circle through that because this is going to be zero force, and that ended up solving for one of the members we want to look for. So we can write right at the top, BD equals 0. And we can go all the way down here and say it's 0. And you can write in units or not, it's 0. There's really no units to write in. So we've got that as a zero force member. And that's by inspection here. Maybe you could write a little explanation or something. But ultimately, as long as you can just show on here that it equals 0, you should be good to go. Next is AB and BE. Now, you could go through and do method of joints from C to B. In fact, that actually looks like the easier way. The other way is method of sections through here, where you expose all of these internal forces here. I might do that too, just so you guys get a grasp, because there might be an exam problem where it's not easier. But method of joints is always reliable, can work in every situation. Method of sections, maybe not. So I'm going to go ahead and do method of joints starting at C and then go up to B. Well, for doing that, we're going to need FBDs of them. So we're going to go with FBDC. We'll underline that. So we'll go ahead and draw a point here. We're looking at point C. And so what we've got acting on C is we've got CY going upward, which we solved as 16.67 kips. Next, we've got CD going to the left, and it's horizontal. And then we've got BC going kind of upward at an angle. Another piece of advice I have in here for trusses is don't calculate the angles. Just go ahead and use these little angle triangles or whatnot. So I think they're easier to do than angles. They're basically doing the same thing, but instead of, if we were to solve for this angle, we would take the horizontal dimension, or the vertical dimension and the horizontal dimension, and we would take the inverse cosine of that. But then when you use that to solve for your problem, you would end up taking the cosine of that angle. Well, essentially we're cutting out the middleman, and instead of finding the inverse cosine, we're just going to leave these as a fraction. So we've got 2 here and 2 here. This is going to be, the square root of 8 is going to be this little hypotenuse here. So 2, because we've got 4 plus 4 is 8, and the square root of that, square root of 8. We're going to leave them as a fraction instead of taking the cosine or sine. So we're going to use our equilibrium equations here. The first one we should use is solving for the forces in the y, and we should do that because we only have one unknown in the y, and that's BC. If we solve for the forces in the x, we've got CD and BC, and it gets confusing. And we'd have to solve for one of them anyway to solve for the other anyway. So we could just stick with the one unknown. So some of the forces in the y, we've got 16.67, and that's just going straight up. Plus, we drew this going up and to the left. So if it's up and to the left, we just want the y coordinate. We're going to have plus BC. And then to get just the y coordinate, we're going to take 2 divided by the square root of 8. Now in this problem, because this is square, it doesn't really matter which fraction you use because this is a 45-degree angle. So just kind of like how if you were to take the cosine or sine of 45 degrees, it's the same thing. Ultimately, if you take either of these fractions, they'd be the same angle. So we're just going to say 2 over the square root of 8, knowing that it's this vertical 2 and this hypotenuse here. Those are the only two things we really need there. So we'll go ahead and set that equal to 0, or the only two forces acting in that. So setting that equal to 0, we get that BC is going to be equal to, we're going to end up having a negative 16.67, and we're going to divide it by this fraction here. So divided by 2 over the square root of 8. And we end up getting a negative 23.57. That ultimately means that because it's negative, we originally drew BC going outward like it was in tension. Because it got a negative number, it's actually in compression. So I'm going to write compression, but it doesn't matter for the time being. This is just showing our work because BC is not one of the forces we're solving for. I'm going to go ahead and box our answer for BD up here. So we've got BC. Now, we could solve for CD, but we don't really need to because the next joint that we're going up to is B. And once we're at B, we need to solve for BA and BE. Well, we don't really need CD for anything of that. So I'm going to go ahead and save some time and skip solving for CD. And we're going to go ahead and move up to joint B. Joint B. So at joint B, we can draw the free body diagram. We've got a point, and then we've got, acting on the point, going straight down, 20 kips applied. To the left, we've got AB, exactly horizontal. Then we've got BE going down. And again, the angle is going to be, it goes down 2 and over 2. So it's going to be 2 square root of 8. And then next thing we've got is BD, which is going to be a zero force member. We know that it's a zero force member as we did before. We'll just go ahead and not draw it in because we don't need it. And it's not, it's essentially not there. It is there, but it's not doing anything. So because it's not doing anything, it's not causing a force. We don't need to draw it. The next thing we need to draw is BC. Now, I'm going to go ahead and draw BC just as we found it. We found it to be 23.57. This would have been kips in compression. But because we got it in compression, or like the negative value, that means that instead of drawing it outward like we drew all these other, I'm going to go ahead and draw it pointing toward the point. And that shows that it's in compression. And we'll draw this at just an even 23.57. It's not negative 23.57 in this case because we already drew it going in the, using air quotes, negative direction. Because the positive direction would be going outward. Hopefully that makes sense. And the angle of this is going to be the same as it was before, same as this one. It's 2 square root of 8. So now we can go ahead and solve for AB and BE. And this is just equilibrium equations again. So I think looking at this, we're going to want to solve for the forces in the y first off again. Because if we solve for the forces in the x, we've got AB and BE acting in the x direction. But if we solve for the y, since AB is completely horizontal, I'm drawing this line just for reference. You don't need to draw something like that. Y, it's completely horizontal. It won't have any forces in the y. So we'll go ahead, sum for the forces in the y. This might get a little cramped here. I'll have to draw underneath. But we're going to have, we've got negative 20, because it's 20 kips acting downward, plus, and this is drawn going upwards, so it's going to be 23.57 2 square roots 8. And then next we've got BE, and it's pointing down and to the left, so it'll be a negative or minus BE times 2 over the square root of 8. And all of that is going to equal 0, as it usually does in statics. So we're going to solve for that. BE is going to be equal to, get the handy calculator out again. It's like Blue's Clues, the handy dandy notebook. Oh gosh. We'll go ahead and write in negative 20 plus 23.57. I'm going to go ahead and put more figs in from what we got before, just so our calculation is a little more accurate. We're not rounding to the end. And we'll multiply that by our 2 over the square root of 8. We'll go ahead and put that in parentheses and divide that by, again, 2 divided by the square root of 8. We calculate that out. We get, looks like, negative 4.71, and that's our BE. Since it is a final answer, I'm going to go ahead and write it out like this. BE is equal to 4.71 kips, and then I'm going to write in parentheses C. That means compression. You could leave it as the negative point, but I like to be a little more direct in what I write and just say compression. So you and the grader can know, yes, I mean it to be in that direction. Because if you leave it positive or negative, it kind of depends on your free body diagram, and it depends on convention. So if for whatever reason you drew your free body diagram wrong, and you have a negative number, but the negative number actually means tension because that's how you drew it, you're going to want to label actually in tension or whatever you're intending. Because the grader or whatever would look at it and say, oh, he drew it negative, he means compression. But that's not necessarily the case. So anyway, this is one of our final answers. Is what we're solving for is BE. We'll go ahead and write this in the bottom here, 4.71 kips in compression. And then the next thing we're going to want to solve for is AB, and that's summing the forces in the X. So summing the forces in the X, AB we have going to the left, so negative AB. The 20 kips is going straight down, so it doesn't matter. We're going to have 23.5 is drawing going to the left, so minus 23.57, and then 2 over the square root of 8. And then BE, this is where it gets kind of confusing with our signs and all that. I'm just going to go ahead and write it in as BE as the variable in this direction. Because we did get it in compression, that kind of confuses things. I'm going to go ahead, and BE is pointing to the left, so I'm going to write negative BE times 2 over the square root of 8. And that's all equal to 0. Don't mind my, mind my work here. It's going into that. So BE is equal to 0. Well, ultimately, we're going to substitute in the negative 4.71 into BE. For the sake here and showing you guys, I'm writing it out like this just so you can visualize and see what I'm doing here. Otherwise, if you feel really comfortable with it, you can go ahead and just write it out. Instead of writing negative BE whatever, you would end up writing a positive 4.71. But I don't want to confuse you guys, and hopefully I haven't already trying to explain that. But we're essentially, if we rewrite this, it's going to be 22.57. I'm sorry, 23.57. 23.57 times 2 over the square root of 8 minus, and then in this parentheses is where we're going to put in the negative 4.71 times 2 over the square root of 8 is equal to, and we're going to add this AB to both sides, so it's going to just be equal to AB. And this way we can just solve for AB punching that into our calculator. So once again, a handy dandy calculator. We'll go ahead and have negative 23.57 times 2 over the square root of 8 minus negative 4.71 times 2 over the square root of 8. It's a little redundant there, but gets the job done. We're going to end up getting negative 13.34 kips is equal to AB, or we can write it down below for our final answer. It's going to be equal to 13.34 kips in compression. So 13 in our answer box here, we'll go ahead and box that too. 13.34 kips in compression. And that should be how we solve for this exam, or how do we solve this problem in this exam. So trusses aren't terribly difficult. They're not like a complete lots of new stuff in there. Method of sections is a little more confusing, the method of joints, I think, but it can be very handy if for whatever reason we needed to solve for like these three forces here. Instead of drawing a joint here and a joint here and a joint here, you could possibly save time by cutting it in. But in a problem like this, and probably a problem that you're likely to see on the exam, it might honestly just be simpler to draw the joints instead of drawing the sections. That's up to personal preference. I can go either way personally on it. I've shown you guys how to do method of sections before in class, but I feel like that can get a little confusing if you're not totally comfortable with it. But ultimately, just do what you're comfortable with on this. It might take a little more time to do all the joints, but if you're not comfortable with sections, it might take more time to do that. So this exam, I'm assuming again it's going to be 4 problems. Last one was 3 problems, but that was kind of unique. This would probably be 4 problems, I'm assuming, and 22 minutes per problem if you calculate the whole hour and a half, but let's say 20 minutes per problem. These videos are taking a little longer, but that's because I'm stopping to explain things to you guys. But ultimately, yeah, try to save yourself as much time as you can. And not only that, though, but try to do whatever you're comfortable with that you know you're going to get the correct answer on. Anyway, this is how you solve a truss. If you have any questions about it, let me know. But that's all I have for you guys for this problem. So thank you for watching, and good luck studying.